If we look at solving each of these, and I look at my first one here, example 1 gives me x squared plus 7x plus 18 equals 18. I'm hoping that I can use factoring to solve this. I notice it is a trinomial, however, it's not in standard form. So the first thing I need to do is to put it in standard form. In order to do that, all I need to do is subtract 18 from each side, giving me x squared plus 7x minus 18 equals 0. So now if I want to try to factor this, I look at my factoring tree diagram and I ask myself, does this have a GCF? Well, since there's nothing that all three terms can be divided by, I see that there is no GCF. I ask myself, is it in the form perfect square minus perfect square? Since it's not, I won't be able to use a special formula. The next thing I ask myself is it in the form x squared plus bx plus c equals 0? I see that it is. So because of that, I'm going to use my factor sum tables. So I'm going to take factors of negative 18 with a sum of 7. So looking for two numbers that multiply to give me negative 18 and add to give me 7, I see that 9 times negative 2 does equal negative 18, and 9 plus negative 2 does equal 7. So since 9 and negative 2 do work for both pieces of my factor sum table, I'm going to go ahead and say that then this does factor into x plus 9 times x minus 2. This helps me because now I can see that I have x plus 9 times x minus 2, and according to the zero product property, if I have two things multiplying together to equal 0, one of those two things has to equal 0. So next thing I can do is I can take each of those and I can set them each equal to 0. So that means that either x plus 9 has to equal 0 or x minus 2 has to equal 0. Well, solving x plus 9 equals 0, I subtract 9 from each side and I get x equals 9. Taking x minus 2 equals 0, I add 2 to each side, giving me x equals 2. So again, if I think, what does a quadratic equation look like? Well, it looks like a parabola. Since x squared is positive, this would be a parabola that opens up. Not only a parabola that opens up, but a parabola that opens up and has x-intercepts of x equals 9 and x equals 2. If I now look at example 2, looking at example 2, the first thing I need to do is I do need to get it in standard form so I can then determine which method I'm going to use to solve my equation. So I'm going to go ahead. I do not like to have a negative on my x squared. The reason being is because it sometimes makes it harder to factor. So rather than subtracting 2x squared from each side, I am going to subtract 6 and add 4x to each side of my equation. Again, remember that our commutative property tells us it does not matter what order we add or subtract in, so I am going to make sure it's in standard form and my exponents are in descending order, giving me 2x squared plus 4x minus 6 equals 0. So as of now, we've learned two different methods for solving quadratic equations, the first being taking square roots. Remember, I can only take square roots if I don't have an x term, so because of this 4x here, I'm not going to be able to use square roots as a strategy for solving this quadratic equation. The other method we've learned is by factoring, so if I check to see if I can factor this quadratic equation, going through my factoring table, the first thing I notice is I should always check for a GCF. Well, because 2, 4, and 6 can all be divided by 2, I'm going to take that GCF of 2 and put it out front and have 2 times x squared plus 2x minus 3 all equal to 0. Remember that sometimes taking out a GCF is all we need to do, whereas other times a GCF is only a first step and whatever we're left with can still be factored further. If I look at x squared plus 2x minus 3 and I go back to my factoring table, I've already taken the GCF out. Because it is not in the form perfect square subtract perfect square, I notice I cannot use my special formula. Because it does have x squared plus 2x minus 3, it is a trinomial with a coefficient of 1 on my quadratic term, I see that I can use a factor sum table. So I'm going to do factors of -3 with a sum of my middle, which is 2. Well, I see that 3 times -1 gives me -3, and 3 plus -1 gives me 2. Since those work, I see that this does factor further to be 2 times x plus 3 times x minus 1 equals 0. The next thing I can do is I can set each of these 3 pieces equal to 0 because I do have 2 times x plus 3 times x minus 1, and the zero product property tells me that if I multiply, one of those terms has to equal 0. So either 2 equals 0, x plus 3 equals 0, or x minus 1 equals 0. So if I look at each of those, I can see that it doesn't make sense that 2 is going to equal 0. That will never happen, so I don't have to worry about that. If I look at x plus 3 equals 0, if I subtract 3 from each side, 3 from that 0 that I have squeezed in there, I get x equals -3. If I look at x minus 1 equals 0, if I add 1 to each side to get x by itself, I see that x equals 1. So again, if I were to graph my original function here, this quadratic equation, I would notice that I do have x-intercepts of x equals -3 and x equals 1. Moving on to the next page. I'm recording. If I want to look at solving this next quadratic equation, I have 16x squared equals 8x. Again, my first step needs to be to put it into standard form. You can leave that on. In order to do that, I'm going to go ahead and subtract 8x from each side, giving me 16x squared minus 8x equals 0. So again, I go through my steps of solving quadratic equations. My 2 methods for solving quadratic equations are square roots and factoring. If I try to use a square root on this, I notice that I run into an issue because I have my x term here, and I can only use square roots if I do not have an x term. So that tells me I should try factoring. So I go to my factoring table. I notice that 16x squared and 8x do have a GCF. They have a GCF of 8x. So if I take out 8x, well, 16 divided by 8 leaves me with 2. X squared divided by x leaves me with just an x. Minus 8x divided by 8x leaves me with minus 1. Since anything divided by itself does give me 1. 8x divided by 8x does leave me with that 1. Now if I read this out loud, I do have 8x times 2x minus 1 equals 0, which means one of these pieces has to equal 0 according to our zero product property. Well, that means either 8x has to equal 0 or 2x minus 1 has to equal 0. I could separate the 8 and the x and say either 8 equals 0, x equals 0, or 2x minus 1 equals 0. I will come to the same result either way. Solving this first equation first, I can divide each side by 8, leaving me with x equals, remember it is okay to have 0 on top. 0 divided by 8 is just 0, giving me my first solution. If I then solve this equation here, I add 1 to each side, leaving me with 2x equals 1. I can then divide both sides by 2, giving me an x value of 1/2. So once again, I now have solved my quadratic equation, giving me x-intercepts of x equals 0 and x equals 1/2. Looking at the last example, it says to find the x-intercept for the function y equals x squared minus 4x plus 4. First thing I recognize is that if I am going to solve for an x-intercept, whether it is quadratic, linear, cubic, any kind of function we deal with, if I am solving for an x-intercept, I remember that the only way I can get an x-intercept is by having a y value of 0. Again, it does not matter if I am quadratic or if I am linear, either way. So the first thing I'm going to do is use that fact and put a 0 in for y. And now I'm going to ask myself, can I solve this equation for x? This would be a good place for you to press pause and try to solve this quadratic equation. Okay, so going ahead and solving this, I'm going to ask myself, do I need to use square roots or am I going to use factoring? Well, because of this term right here, I cannot use square roots. So that tells me to try factoring. I look for a GCF. There is nothing that all three of these terms can be divided by. I look to see, is it in the form a squared minus b squared? It is not. So the next thing I ask myself is, can I use a factor sum table? Well, because it is in the form x squared minus or plus bx plus c, I can use a factor sum table. So I will do factors of the last with a sum of the middle. Please remember the sign belongs to the number, so I do need a -4 there. Well, I see that -2 times -2 does multiply to be 4, and -2 plus -2 does add to be -4. Because that works, I see that this can be written in factored form as x minus 2 times x minus 2. Why is that helpful? Because now I have multiplication going on. I have x minus 2 times x minus 2, and according to my zero product property, either x minus 2 equals 0 or x minus 2 equals 0. Since they are both the same, I only need to solve one. So if I add 2, I get an x value of 2, and this is my x-intercept. What you will notice if you graph this quadratic equation is this is called a double root, since it happens twice, and it means that the vertex will end up falling at x equals 2. That is why it occurred twice, or I got the same piece for each of these.